Absolute value equations, lesson 3, quadratic. So this time, the function that we have inside of our absolute value signs is a quadratic expression. We're going to use the same process. So we have two cases. Case 1, where what's inside of our absolute value is a positive amount. And case 2, where what's inside of the absolute value is a negative value. Okay, solving case 1. I'm going to subtract 1 from both sides so that I can make my equation equal to 0. And I end up with x squared minus 2x minus 1 equals 0. I want to solve this equation. Well, it's just a quadratic equation, however, it's unfactorable. And so we're going to use the quadratic formula to solve it. So the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So substituting in, we end up with x being equal to negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 1. All of that is under our root sign, all over 2 times a, which was positive 1. Simplifying, we end up with x being equal to positive 2 plus or minus. Underneath that square root sign, it all simplifies to positive 8 all over 2. The square root of 8 is 2 root 2 all over 2. 2 will divide into all of the 2's that are outside of our root sign, and we end up with x being equal to 1 plus or minus the square root of 2. So that gives me two possible values there. Let's go back up to case number 2. In case number 2, I want to multiply both sides by negative 1 or divide by negative 1, and I end up with x squared minus 2x equals negative 1. Making the equation equal to 0, I'm going to add 1 to both sides, and x squared minus 2x plus 1 is equal to 0. This one is factorable, and in fact factors into two factors that are the same of x minus 1 and x minus 1. So my possible solution here is that x equals positive 1. I now need to verify each of those solutions. Start by verifying that x is equal to positive 1. So I'm going to substitute in positive 1 into the original equation. And I end up with positive 1 squared minus 2 times positive 1. Absolute value has to be equal to 1. So that's what I'm trying to show. So the absolute value of 1 squared is 1 minus 2 is equal to 1. The absolute value of 1 minus 2 is the absolute value of negative 1, which is equal to 1, so that solution works. Verifying one of our other two. Let's verify that x is equal to 1 plus root 2. So same idea, the substitution just gets a little bit more complicated. And so we end up with, instead of x squared, we have 1 plus root 2 squared minus 2 times 1 plus root 2. All of that is in absolute values, and I want to show that it is equal to positive 1. One plus root 2 squared means 1 plus root 2 times 1 plus root 2. So if I write that in here, remember that we need to now distribute. So I'm multiplying the 1 times 1, so inside absolute value signs, I end up with 1 plus 2 root 2 plus 2. That's what I get when I do 1 plus root 2 squared. Then I need to distribute this 2 into here, and I end up with minus 2 minus 2 root 2. All inside the absolute value sign, and I want to see whether or not that is equal to 1. So inside the absolute values, I can do some simplifying. 2 root 2 and minus 2 root 2 cancel out. Positive 2 minus 2 cancel out, and I end up with the absolute value of 1 is equal to 1, so that solution also works. Checking our third solution of x equals 1 minus root 2 is the same process. So we end up with the absolute value of 1 minus root 2 squared. So let's just write it as 1 minus root 2 times 1 minus root 2 minus 2 times 1 minus root 2 in absolute values, and I want to show that that is equal to 1. So again, when I distribute in these first two binomials, I end up with 1 minus 2 root 2 plus 2. Distributing in this negative 2 gives me minus 2 plus 2 root 2. And I want to show that it is equal to 1. Simplifying, positive 2 minus 2 cancel out. Again, my negative 2 root 2 and positive 2 root 2 cancel out. And so inside the absolute value, I'm left with 1. So the absolute value of 1 is 1, so that solution works as well. So all three of our solutions work. So our solution set is 1 and 1 plus or minus root 2. Our next example has both a linear piece and a quadratic piece, but we're going to tackle it the same way. So case 1 is where what's in the absolute value sign, in this case x minus 10, is positive and equal to the other side. Case 2 is where what's in that absolute value sign is negative and equal to the other side. Solving case 1 first. Let's subtract x from both sides. And we end up with negative 10 equals x squared minus 10x minus x. We're going to, actually, sorry, I can combine the negative 10x and the negative x to negative 11x. Next step, add 10. And I end up with 0 equals x squared minus 11x plus 10. To solve it, it's a quadratic equation, so I want to factor. And I can factor this into negative 10 and negative 1. So my possible solutions are x equals 10 and x equals positive 1. Case number 2. I'm going to distribute my negative in, so I end up with negative x plus 10 equals x squared minus 10x. Let's add x to both sides. I end up with 10 equals x squared minus 9x. Subtract 10. And 0 equals x squared minus 9x minus 10. This equation will also factor. This time my factors are x minus 10 and x plus 1. So my possible values are x equals 10 and x equals negative 1. So I ended up with some repeats. I have positive 10 in both sides. So I only have 3 values to verify. So let's start by verifying x equals 10. To verify x equals 10, we're going to substitute in for x. So I end up with 10 minus 10 in absolute value signs has to be equal to 10 squared minus 10 times 10. The absolute value of 10 minus 10 is just 0. And on the other side, 10 squared is 100, minus 10 times 10 is 100, or 0. So x equals 10 verifies. Next, let's verify negative 1. This time inside our absolute value signs, we end up with negative 1 minus 10 equals negative 1 squared minus 10 times negative 1. Negative 1 minus 10 is the absolute value of negative 11. Has to be equal to negative 1 squared is 1. Negative 10 times negative 1 is positive 10. Absolute value of negative 11 is 11 equals 11, so that solution works. Let's verify our last solution, which is x is equal to positive 1. If x is equal to positive 1, when we substitute in, we end up with the absolute value of 1 minus 10. Has to equal 1 squared minus 10 times 1. So we end up with the absolute value of negative 9 being equal to 1 minus 10. So the absolute value of negative 9 is equal to negative 9. Again, I can't have an absolute value equal to a negative, so this solution does not work. And our solution set then just contains two values, negative 1 and positive 10. Our last example for today is an absolute value word problem. It says a computerized process controls the amount of batter used to produce cookies in a factory. If the computer program sets the ideal mass before baking at 55 grams, but allows a tolerance of plus or minus 2.5 grams, solve an absolute value equation for the maximum and minimum mass of batter for the cookies at this factory. So this means that the difference between the mass of a cookie and the 55 grams allowable has to be no more or less than 2.5. So there's our equation. So we end up with m minus 55 can be equal to 2.5, or we can have that the value inside our absolute value, so m minus 55 is equal to 2.5. So those are two absolute value cases. Solving the first one, we're going to add 55 to both sides. We end up with the mass being 57.5 grams. In this one, we end up with negative m plus 55 when we distribute that negative sign in. So we have negative m equals, if I subtract 55 from both sides, I end up with negative 52.5. Divide both sides by negative 1, and our mass is 52.5 grams. This means that our cookie batter could weigh anywhere between 52.5 grams and 57.5 grams.